I'm the professor. So in our earlier videos, we were discussing the divisibility rules for powers of 2, powers of 5, and for 3 and 9. So a question arises in our mind as to how did we arrive at the divisibility rules of these numbers. So there's a logical outflow as to how did we arrive to it. So for that reason, I have assumed PQRSTUV a 7-digit number. So keep in mind that these P to V are 7 digits of a number. They represent the 7 digits. So since we follow a base system of 10, so I have just written it down that 10 to the power 6 into P would be the first number, plus 10 to the power 5 Q, plus 10 to the power 4 R, plus 10 cube S, plus 10 square T, plus 10 to the power 1 U, plus 10 to the power 0 V, since this represents units, tens, hundred, and so on positions of the number. Now let us see. For 2 and 5, if we just consider for 2, so we have 10 to the power 6 is definitely divisible by 2. That is what we know. There's no need to demonstrate it. We know for a fact that 10 to the power 6 is divisible by 2 as well as 5 for that matter. Same with 10 to the power 5, same with 10 to the power 4, same for 10 cube, for 10 square as well. And for 10 to the power 1, which is 10 itself, it is a multiple of 2 and 5. So 10 to the power 1, that is 10, is divisible by 2 and 5 also. So all these digits are a multiple of 2 and 5 with that respect. So 10 to the power 0, which is 1, into V. So we just need to consider the units digit for checking the divisibility rule for 2 and 5. So we just consider the divisibility of V, whether V is divisible by 2 and 5 for the first power of 2 and 5. For second powers, we'll take this along with this because 10 is divisible by 2 and 5, not by 2 to the power 2 or 5 to the power 2, and so on. Now coming to how we arrived at divisibility rules for 3 and 9. So let us just expand this and see what happens. 10 to the power, okay, I'll just write it from this side, V plus 10U plus 100T plus 1000S plus 10,000 R plus 1 lakh Q plus, okay, 4, 5, 6, 10 to the power 6p, right? That is 10 lakhs p. So I've just expanded it. Now if I take 1p, 1q, 1r, 1s, 1t, 1u out of the equation, let's see what happens. So I can write it down as 99999p plus p, 9999, I'm sorry, there would be one more 9 here and one more over here, q plus 9999r plus 999s plus 99t plus 9u, and over here we would have a r in addition, a s and a t and a u, and the v would be as it is. So if we can see that this number, all these numbers are divisible by 3 as well as 9. Again, there is no definite way and to demonstrate this, but we know for a fact that this is divisible by 3 as well as 9. So we just need to check whether the sum of these digits, whether the sum of digits would be divisible by 3 and 9. So for the divisibility rule of 3 and 9, we just need to check whether the sum of digits is divisible by 3 or 9. The reason I have just explained it to you. The same reason was applicable for 2 and 5 and powers of 2 and 5 as well. For 3 and 9, we just differentiated between, we just took out a digit from each of the digits, and the remaining was divisible by 3 as well as 9. So we just needed to check for the sum, whether it is divisible by 3 and 9. Thank you so much. Keep studying, stay safe. I'm the professor. Bye bye.